how are you guys doing? Professor Rhines out in the elements. Today I decided to bring it back into the classroom one last time as we near the end of this 2019-2020 school year. It's been an unusual ending just with our time off during this pandemic and Corona-19, so thought it'd be a great place to come and have a couple lessons and demonstrations today. Before I go to those, I wanted to show you my quote from this year. It tends to be the thing that I say to start off each video and end each video, and it's, hey, how are you guys doing? And peace out. We love you guys. So this will go right up here on our wall of other quotes, and so it's a great one to kind of exemplify what we've had to say and do this whole year. So let's get started on some demonstrations. Okay, got the lab coat on today since it's Professor Rhines, and we're going to be doing some demonstrations. Take off my hat. You can see, yeah, shaved it right down today. That way we're mad scientist-ish as we go in today. All right, hey, some things that I want to talk about. We've been talking about gravity. Gravity is this force that pulls two objects towards each other. We know that the one with the greater mass will pull objects towards it. So right now we're standing on the earth. I have a tennis ball in my hand, and so you think, okay, between the earth and this tennis ball, which one has more mass to it? Which one has more particles smashed into it? That's the one that'll draw it towards it. So do you think the earth is going to come up to the tennis ball, or the tennis ball is going to go to the earth? Well, obviously the earth is much more massive than this, so when we let go of the tennis ball, you can see it start to fall. If I do it off the table right here, gravity is this force that pulls objects down towards the center of the earth, or in this case towards the object with more mass, which the earth has compared to this little tennis ball. So gravity. The other thing I wanted to talk about actually goes along with Newton's three laws. Before I go into those three laws, let's just review Isaac Newton. I put in a question about Isaac Newton last week. I said, what do we have in common? That he had to do e-learning, that technology. Boys and girls, if you read those notes I gave you, the man lived in the 1600s. Awkward silence. 1600s, there wasn't any technology. So the thing that he had in common with us is that he lived through a pandemic. He was sent home from Trinity College, part of the Cambridge University, and so while he was at home and not attending school because of the bubonic plague that was going through, known as Black Death, hey, that's where he did some of his greatest scientific discoveries during that time when he had to be back home and not in school. So it makes us wonder, what kinds of great things are you guys coming up with while you're at home, making some scientific discoveries? So as we talk about that first law of motion, it's about inertia. Inertia is this thing, I actually have it written on the board over here, I don't know if you can see it, but it says inertia. An object will stay or keep moving at the same speed and in a straight line unless it is acted upon by an external or unbalanced force that gets it moving. So in other words, an object at rest stays at rest until a force acts upon it. Or an object in motion should just go in motion forever until a force acts upon it. Well, in this case, it's rolling, 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 but gravity and friction, which is two forces rubbing against each other, are eventually going to slow that thing down. When, Mr. Rhines? I don't know. Give it some time. Patience. As my dad always said, patience before you become one. We're going to roll the other way. Eventually it'll stop. So that's Newton's first law of motion. An object in motion will stay in motion forever until a force acts upon it, and we have forces that will act upon this. Or an object at rest will stay at rest until a force acts upon it and gets it moving. That's inertia. Another way that we can see inertia actually causes object to go in orbit. Our planet is in orbit, a revolution, an orbit going around the sun. You say between Earth and the sun is huge. We studied the sun back in the fall. You're like, why isn't the Earth pulled into the sun? Good question, because gravity, you would think, would force it to do this, but we're also in motion, and that wants to fling us out into space. So when you have these two objects fighting it out, duking it out, one is wanting to draw us in, one is wanting to fling us out into space, and so between those two forces of gravity and inertia, object in motion stays in motion until a force acts upon it. It causes us to make this curved arc in orbit. If this is the Earth and this is the sun, the Earth wants to be pulled in by gravity and flung out by inertia, and so it causes this arc known as in orbit. I can show you that actually real quickly. I just happen to have a bucket and some water. I don't know, I grew up on a farm, so this was something to entertain us, I guess, when we carried water out to the barn, because we didn't have a spigot or a way to turn on water out in our barn. We had two of these. We'd fill them up and carry them out to the barn. Sometimes you'd make 2 trips if the horse had drank a lot of extra water that day. But while we were traveling out there and slowly putting water in for the goats, the horse, the rabbits, the chickens, you'd have just a little bit, and sometimes to occupy your mind, you'd start spinning this thing. Oh yeah, there's water in here. Can you hear it sloshing? See it splashing out? I can pour a little. Oh, right there. So it's in here. But when I'm spinning it, gravity wants to bring it down. Inertia wants to fling it out. And so I can make this orbit. I can swing it around, and the water stays in there. I better bring it down quick, because otherwise it'll splash like it did right there. Inertia comes up, comes around, comes up, comes around. Gravity wants to bring it down, inertia wants to fling it out, and so it makes an orbit. Another way you see that sometimes, maybe you've seen like the old time slingshots. I don't mean the kind where you pull it back and let the rock go or the stone go in the pocket of that slingshot. I mean the old kind where they would spin them like this. Sometimes you might see that in pictures or stories like from David or Goliath. And it involved a bunch of strings and a pouch, so I'll just use this. We'll call it the sling sock, not a slingshot, a sling sock, because this is an old tube sock. And so I've got this little stone, and if I put that stone in this pocket, the same principle would apply. They would put it in orbit and swing it around, or maybe even swing it like this, and then they would let go of one end of that and a certain place in the arc, and then that stone would come flinging out from there. They'd swing it, swing it, swing it, swing it, swing it, and then let go of one end of those cords, and it would release the stone out of the little pocket. Kind of like this. I'm in a classroom, so I have to be sort of careful with it, but if I hold this so I can let it go, I'm going to spin it, spin it, spin it, and let it go. And it went flying across the room over there. So, all right, that's all in regard to Newton's first law of motion, inertia. When you have gravity pulling in, inertia flinging out, it puts things into orbit. And so when I let that go, inertia took off and ding, it went flinging out in that straight line like it wants to, because an object in motion wants to stay in motion. Eventually gravity brought it down to the floor, and when it bounced along the floor, friction of the rock hitting the floor slowed it down, and now it came to a stop. All right, so that is Newton's first law of motion, inertia. I'm going to cover the second and third law in relation to gravity later this week, but welcome back to Mr. Rhines' classroom. And so like we like to say, like my saying for this year's class, peace out, we love you guys, and we'll see you along the way.